Hey everybody, let's give this op-amp problem a try. And this one has a potentiometer here. And you can think of it like, let me just sketch it real quick. Okay, so there's this 50K resistor that's kind of splitting up these two resistors like that. Okay, so where this whole thing is 100K, but then if you turn it's kind of like you can turn the knob to pick how far along it goes. So like if, right, so this bottom part is labeled alpha times R, so 100K. So for example, if you turn the knob where alpha is 0, right, then this is 0 and this is 100K. Or if you turn the knob the other way, then this side is 100K and this side is 0. Or if alpha is just right halfway in between, this is 50K, this is 50K. Okay, so that means up here is actually the leftovers, 1 minus alpha times 100K. Okay, so let me just label these nodes. I'll call this node N, I'll call this node P, this is my output, and I'll just call this node A for lack of a better letter. Alright, so how do you analyze op-amps? You just write KCL at these nodes. So let's start with KCL for node N. So let's write the current going toward the left. Vn minus Vg, which is actually 40 millivolts over 2 kilo ohms. Okay, now the current going toward the right over here. See over here? So I'll just call that IN. Right, and now the current going up would be Vn minus Va from this node to this node divided by 50K. And that's it. All right, now let's write KCL for node A over here. KCL for node A. So going toward the left, Va minus Vn over 50K plus, let's go down this way, Va minus 0 over alpha times 100K. And then now let's go up and around this way, plus Va minus V out over 1 minus alpha times 100K. Okay, so there we go. We got two equations using KCL, but then notice that this op-amp is ideal. So that means the current going in this way is 0, so this is 0. And also the voltage here is the same as the voltage here. Vn equals Vp. This is always true for an ideal op-amp. For this particular circuit, Vp is tied straight to the ground. So in this particular circuit, Vp is 0, which means Vn is also 0, which means I can cross this out, and over here, and over here. Okay, and let's just take a look at our unknowns. Va, V out, and alpha. Okay, so by doing that, by underlining the unknowns, look, that equation only has one unknown, which means we can solve for Va immediately. Let's see, if we multiply everything by 50,000, then that'll be 20 over 22, it's just -1. Okay, so that worked out nicely. Oh, which means I can just plug it in right there, and there, and there. Can I just do that immediately? Okay, -1 over, okay, can I multiply this entire equation by 100,000? Okay, so if I multiply everything by 100,000, then this is -2. Okay, and then, let me do it a little slower. V is -1. Okay, -1. -1. Okay, now let me multiply everything by 100,000. And this becomes 2. Okay. Just clean this up a little bit. Okay. And now let me just split this up. -1 over 1 minus alpha minus VO over 1 minus alpha. Okay, and then I can move this to the other side, like that, and then multiply everything by 1 minus alpha. Okay, so there is V out. I'm sure I can simplify a little bit, but okay. Let's simplify just a little bit. Okay, so this times this minus 2 times 1 minus alpha minus 1 over alpha times 1 minus alpha, and then this times this would just be -1. Okay, and then let me multiply this through. -2 plus 2 alpha minus 1 over alpha plus 1 minus 1. Okay. There we go. So that's the output voltage as a function of how much you turn that potentiometer dial. And then, actually, we wanted the range. So you just plug in these two numbers when alpha is 0.2 and alpha is 1. So let me just pause and just punch in the calculator so you have some numbers. Maybe the numbers are simple enough. So when alpha is 0.2, minus 2 plus 0.4 minus 1 over 0.2 is 5. So -7 plus 0.4 is -6.6. V out at alpha equals 1 is -2 plus 2 minus 1, which is -1. Okay, so if we crank the dial all the way to 1, where alpha is 1, then the voltage is -1. When we turn the dial down to alpha is 0.2, then it becomes -6.6. But we have to be careful because the op-amp, the output voltage can't just be whatever we want, right? It has to be between 7 and -7. Okay, so let's be careful there, right? 7 and -7. So if we turn the dial all the way where alpha is 1, no problem. But we have to watch out. If we make alpha even less than 0.2, we might have a voltage that goes below -7. So you have to keep an eye on that. So that's part B, if alpha is not restricted, where you can just turn the dial as low as you want to go, when will it saturate? It might not, or it might be somewhere in between 0 and 0.2. We don't know, right? So what happens in this range? Is it going to saturate? Is it going to go below -7? That's what we have to watch. Okay, so let me just copy and paste this. Okay, so this is the output voltage as a function of alpha, but we have to be careful that it doesn't go below -7. That's what we have to watch out for. Okay, so when does that happen? Here, I just wrote it, right? There. So let's solve this. Okay, let's see. This is bothering me, right? Let's multiply this entire equation by alpha. Minus 2 alpha plus 2 alpha squared minus 1 equals -7 alpha. Okay, let's move this on this side. So we got 2 alpha squared plus, so that'll be plus 5 minus 1. Okay, and then we just solve this quadratic, and then we're good, right? So let's just divide everything by 2. Let's factor a 2 out of here. 5 halves is the same as 2 times 5 over 4. Okay, and then the quadratic is negative this thing plus or minus square root of this thing squared minus this, minus -1/2. There you go. Okay, and then just punch that in the calculator. Let me just pause. Okay, so, well, you're going to have 2 answers, right? Where one of them is going to be negative, right? Because it's going to be -5/4 minus something, and the other is going to be -5/4 plus something. So we can't have alpha being negative, right? That's like turning the dial below 0. So that's not going to have any physical meaning, just this one. Okay, so 25 over 16 plus 1/4. So this one, and then I punched that in the calculator, and I got about 0.186. Okay, so then alpha can only be in between 0.186 and 1, right? Because if alpha is all the way down at 0.186, then the output voltage will be -7, and then at 1, the output voltage will be, what did we get? Here, -1. So then there. So this is the answer for part B. Okay, so let me know if you have any questions about this. Hopefully it's helpful. I'll see you on the next video.